All right, let's go, kiddos. Hey, if you're not subscribed, please do so. There's a free PDF in the description. It's in English and Spanish. Go ahead and download it and give it to yourself, give it to your class, give it to your kids, whatever you want to give it to. Hey, tell people around the whole world what we're doing here. That'll make life great for all of us. All right. Now let's make sure we put our electronic devices down and let's clock it and lock it, my people. This is single variable word problems, practice worksheet. Refer to the given word problem. Johnny is thinking of the following number. 8 more than 5 times a number is 53. What is the number? Okay, so we got to think about some wording here. 8 more than, that's some words we need to be aware of. 5 times a number, that needs to be a word we're aware of. The word is also a really important word. I think we know what 53 means, so I ain't going to highlight that. Okay, so 8 more than a number. Okay, if I'm 8 more than a number, then that means I'm adding 8 to it. What am I adding 8 to? I'm adding 8 to 5 times a number. Now, a number means a variable, so I'm going to say n for number. So 5 times a number, times means multiplication. Boom. So that is 8 more than 5 times a number. The word is always means the equal symbol, and then 53. That's your equation. All right, so one step at a time, my people. Let's solve this thing now. Okay, so to do this, I'm going to do inverse operations. This is why we taught you how to solve equations, so you could progress in your mathematics. This is why every step is important. Be engaged in every step, and you will become a good mathematician. I promise you. Just stay strong, stay engaged. All right, now we're going to go ahead and do the undoing of multiplication. That is division. Okay, I think Johnny's thinking of the number 9. Johnny's thinking of the number 9. 5 times 9. I'm going to go ahead and check this on my calculator because, hey, why not? If I check it, I can verify that I got it correct. All right? So I'm going to do 5. I'm going to do this over here so you can see it. I'm going to do 5 times a number, but I know what that number is. That number is 9 plus 8. And if it equals 53, we good. Woo, we good. All right, moving on. Kaya is thinking of the following number. 3 times the difference of, okay, so 3 times, that's important. The difference of, this is also important. This means something new. A number and 9. Right there. And then we all already know that the word is means the equal symbol. I think you know what 12 is. All right, so let's talk about this. All right, so 3 times. I'm going to do that. The difference of implies parentheses. All right, so that implies parentheses. I want to do the difference. I'm going to do 3 times the difference of. So I want to do the difference of first. A number, I'm going to call that n, and 9. Difference means subtraction. Okay, so the difference of a number and 9. There it is. That's 3 times the difference of a number and 9. Is, that word is means equals, always, 12. All right, that ain't bad. That ain't bad. Let's solve it. I'm going to take it down here. That equals 12. Okay, you remember this thing called distribution, right? This is why we practice it right here. So that's 3 times 1n is 3n. A positive times a negative is a negative. And then 3 times 9 is 27 equals 12. Okay, in versal operations, I'm going to do the opposite of minus 27 because I want to get this variable term by itself. The goal is to get the variable term by itself initially. So we'll do that first. That's going to be plus 27. Now we're going to rewrite it. Always rewrite it after you do a step. Don't try to do shortcuts. That's where most people make their mistakes. Okay, now my goal is to get the n by itself. So first the goal is to get the variable term by itself. Then I want to get rid of the coefficient, the number in front of n. It's always multiplication when you have a number next to a variable. Inverse of multiplication is division. This turns to 1n equals 13. All right, that's it. Let's see if we did it right. I'm going to go back to my calculator, and I'm going to substitute this in and see if we did it right. So I'm going to do 3, open a parenthesis. Now where I see the n, I'm going to put a 13 minus 9, and if that equals 12, we're good. Woo, we good, we good. All right, let's do the next one. Oh, good old Mario. He's a good guy, that Mario. Mario is thinking of 2 numbers. Oh, not just 1, but 2. Oh, and here's the sum of 2 consecutive integers. Okay, so there's a word sum. That's important. And then there's this thing called 2 consecutive integers. And then there's that wonderful word is. And then there's that 97. So I know I'm going to equal 97. All right, let's talk about consecutive integers. What does that mean? Consecutive means one after the other. So if I give you the integer 4, by the way, an integer means non-decimal, non-fraction. It can be positive or negative, but no decimal, no fraction. The next integer, if you're counting, would be 5. Those are consecutive. Let's try another one. If I have 11, the next consecutive integer is, you tell me, 12. Ooh, I heard it a lot out there. Good job. Okay, now ask yourself this. How do I get from 4 to 5? By adding 1. Very good. How do I get from 11 to 12? By adding 1. So if I say that the first integer is x, because I don't know what it is, what's the second one going to be? It's going to be x plus 1. Okay, so this is the first integer, and this is the second integer. Notice I'm going to take the sum of them. Sum means addition. So I'm going to take the first integer plus the second integer, and that is 97. Now the reason I put parentheses around there was just separate it so you could see the first and second integer. That represents the sum. The parentheses are really meaningless because there's nothing to distribute. If that was a minus, then I would distribute the minus through. But really, I could write it like that. That has got to be one of the worst 7s I ever wrote. Okay, so there's that. So write an equation. Can I simplify it first? 1x plus 1x. 2x. Good job, good job. That's your hard work paying off. That's 2x plus 1 equals 97. Okay, now let's solve this. So remember, there's that variable term. All right, I want to get that by itself. So I'm going to move that constant 1 over. So the inverse operation of plus 1 is minus 1. Boom. That gives me dos x equals 96. And now here's the last move. Always divide by the number in front of the variable. Divide by 2, divide by 2. Because when you divide something by itself, it's always 1. This means my next step. 2 divided by 2 is 1x. That was my goal. And then 96 divided by 2 is 48. Okay, remember, x is the first integer, right? X is the first integer, and x plus 1 is the second integer. So x is 48. That's my first integer. 48 plus 1 is 49. I think I got it. I think I nailed this. Let's try it. I know if I add those two numbers up, it's got to equal 97, because that's what they told me. The sum of them is 97. So 48 plus 49 is 97. Let's go. We're doing great. Okay, let's keep going. Stay strong. Remember, don't let distractions get in your way of your success, right? That's important. Sammy is thinking of a number. The sum of, oh, there's that word sum again. There's that word sum. That means addition. But look at, we're taking the sum of 3 consecutive integers this time. All right, so the sum of 3 consecutive numbers, all right, is 27. Okay, so remember that word is means equals, so let's highlight that. Always means equals. Put it in your notes if it's not in your notes already, and make sure you refer to them. Okay, let's talk about this now. 3 consecutive integers. All right, the first integer, I'm going to go right here. The first integer, I'm going to call that x. By the way, let's take a look and see what 3 consecutive integers look like. 3 is the first one. That's x. What's the next integer? That's right, 4. So x plus 1. And then what's the next integer? That's right, 5. Okay, so now how do I associate x, right, with that? What do I have to add to 3 to get to 5? 2. That's right. So I'm going to call that x plus 2. I'm going to highlight these. That's the first integer. That's the second integer. And that is the third integer. Okay, now let's do this. First, second is the first one plus 1, and the third is the first one plus 2. Always. Now remember that word sum, right? Right there. That means addition. So I'm going to take the first integer plus, because I'm going to sum them up, the second integer plus the third integer. And that is 27. Okay, let's simplify the equation before we put it there. Do you remember what 1x plus 1x plus 1x is? Ooh, 3x. All right, then we have positive 1 plus 2. That's plus 3. Notice how I did no inverse operations because all of those terms are on the same side of the equal symbol. That equals 27. That is my simplified equation. I would let you put that down, but you can also simplify it first. That'd be good. All right, let's solve this thing. Find out what our first integer is. Remember, get that variable term by itself. Get that variable term by itself. So I'm going to subtract 3 and subtract 3. I'm going to go up and over here. That gives me 3x equals 27 minus 3, because that went to 0, is 24. Okay, now I want to get the x by itself. I want to know what 1x equals. So the inverse operation of multiplication is division. X equals 8. All right, now let's do some problem solving. Okay, if x is 8, that means that's this one right here. Right? First integer is x. That's 8. I'm going to write that down. Okay, the second integer is, oh, sorry, I dropped my pen, is 8 plus 1. That's 9. And the third integer is 8 plus 2. That's 10. See how they're consecutive? 8, 9, 10. That's what it means to be consecutive. So I'm going to write down 9 and 10. Let's do a little check. So if this works, I should be able to add those 3 things up, and it's going to equal 27. So 8 plus 9 plus 10. Woo, let's go, let's go. All right. Deep breath. We still got another half page to go. Here we go. Uh-oh. Now we're talking, now we're talking. We got Alice here. Alice is 4 years younger than Dahlia. Ben is 6 years older than Dahlia. The sum of their ages is 4. Use the equation you wrote to find each person's age. All right, let's highlight some things. I like to read my word problems first because then I got an idea of what I'm trying to accomplish. So what I'm trying to accomplish is to figure out how old all these peeps is. That's what I'm trying to accomplish. And then notice the sum of their ages is 44. Okay, so that's all important information. There's a lot of important information. Let's write an equation for Alice and Dahlia. All right, Alice, that's A, so I'm going to let A be Alice. There's that word is. There's that word is. Whenever you see it in a mathematical word problems, that means equal is 4 years younger than. What the heck does this mean? Well, that means subtraction, right? If I'm 4 years younger, that means I'm Dahlia's age minus 4. I'm going to call Dahlia Dahlia. Right there. Now we got Ben, good old Ben. Ben is, there's that dang equal symbol again. I love it. Ben is 6 years older than Dahlia. So if they're older, then that means you're going to add, right? Older is addition. because I'm getting more. So that's Ben plus 6. Well, we're missing a person because there's 3 people. People. And the person we're missing is Dahlia. Don't forget about Dahlia, all right? Oh, I made a mistake. Who knows what it is? That's right. This should not be a B. We're comparing Ben to Dahlia. Okay. Let's write our equation. The sum of their ages. Sum means addition. So I'm going to take this plus this. Got to get the right color. Plus this. And that is 44. Remember, that is the equal. So let's do it. I got Alice. Well, here, I'm going to do this first, if that's all right. What I'm trying to say is Alice plus Ben plus Dahlia is 44. That's my equation. But I got too many variables. Notice I know that Alice is Dahlia minus 4. So I'm going to take Alice out, and I'm going to write Dahlia minus 4. Now the sum means I'm going to add Alice to Ben, but Ben in terms of Dahlia is D plus 6. And Dahlia is Dahlia. Now I got one variable, and I can solve a one variable equation. Okay, let's simplify it. So I got 1, 2, 3D, and then I got negative 4 plus 6. That's 2. Notice no inverse operations, right? All I did was simplify things that were on the same side of the equal symbol. I'm seeing a lot of people doing inverse operations when you're staying on the same side. If you stay on the same side of the equal symbol, there's my equal symbol right there, then you do not do inverse operations. You just do the order of operations, right? Combining like terms, distribution. That's important. A lot of you are making your mistakes because you're doing inverse operations on things that are on the same side of the equal symbol. Only when you move from here to there do you do inverses. All right, that's my equation. Write down. Okay, let's find Alice. Oh, actually, we're going to find Dahlia first. Okay, so inverse operations. Get that D term by itself. Okay, so you got minus 2 and minus 2. That gives me 3D is equal to 42. I'm going to take it up here. All right, now I got 3 times D, so I want to figure out what that is. So I'm going to divide both sides by the 3. Ooh, use red. Use red, fool. So Dahlia, 42 divided by 3. Is that 14? I think it is. Dahlia's 14 years old. And let's go ahead and put in that unit of measurement for full credit. I don't want to take a half point off because you forget that. Okay, now Alice. Alice is Dahlia's age minus 4. So 14 minus 4 is 10 years old. And then we got Ben. Ben is 6 years older than Dahlia. So 14 plus 6 is 20 years old. All right, now that's a lot of work. And I want to get an A on this test. So I'm going to check to see that they add up to give me fofo. So I got 10 plus 14 plus 20. Let's go. 44, yes. All right. Number 6. Oh, our good friend Don. Don, I'm going to go ahead and read it. Don has 4 times as much money as Mia. This is very similar to this. It's just I'm using different context. It's money, right? Chris has $15 more than Mia. Mamma mia. They have a total of $381. All right? So a total of $381. So the 3 of them added up have $381. So that means Don plus Chris plus Mia is equal to 381. All right, well, I got too many variables. So what do I know? I know that Don has 4 times as much money as Mia. Okay. Chris has $15 more than Mia. More than means you're adding 15. Okay. Notice here, Don equals 4M. And there's Don right there. Notice here that Chris equals 15M. And that's right here. So let's go ahead and substitute that in. So instead of Don, I'm going to put 4M. Instead of, there's the plus. Instead of Chris, I'm going to put M plus 15. And then notice how everything's in terms of M, so I'm just going to bring the Mia down. Equals 381. A lot of people forget about the person we're comparing to, which is Mia. We're comparing Don to Mia and Chris to Mia. So don't forget about Mia. She's a person. So now look at my M's. Look at my M's and look at how they're all on the same side of the equal symbol. So I'm doing no inverse operations. All of this is on the left side. So just combine like terms. There's 4M, 5M, there's 6M. So that's 6, oh, I almost wrote in the wrong color. That's 6M plus 15 equals 381. All right, that's my equation. Okay, now let's solve this thing. I'm going to subtract 15. I want to get my 6M term alone. So I'm going to move my constant over. Notice now I'm doing inverses because I'm going over the equal a symbol is equal to, oh my, what is that? Let's see. Boom, boom, boom. That's 366. All right, now I'm going to divide both sides by 6 because I want to know what Mia is. I don't want to know what 6 times Mia's amount is. I want to know what one of Mia's amounts is, right? What is Mia equal to in money? So I'm going to divide by 6 to make that 1 Mia. Divide by 6. So 1 Mia is equal to, 6 goes into 36 6 times. 6 goes into 6 ones. Don't forget unit of measurement. Mia has $61. Okay. Chris is Mia plus 15. So Chris is going to equal 61 plus 15. That's going to give me 76. So Chris is 76. Don is 4 times Mia. So 4 times 61, that's 244. That's right, 244. Okay, now what I'm going to do is I'm going to check to make sure I got this right. So I'm going to add them up, and if I add it up, it should equal how much money? Should equal 381. Let's do it. I got 61 plus 76 plus 244. Hey, let's go. All right, one more problem to go. Don't look at that phone. Don't get distracted. Stay strong for you. Okay, there's a lot going on in this one. A lot going on. Okay, so I'm going to have to get a couple more highlighters. So I'm going to. Okay, your friend says that if you can guess the number of green Skittles in the bag, you can have them. Ooh, I love some green Skittles. All right, there are 3 times more red Skittles than green ones. Okay, so I'm going to highlight that. So 3 times more red than green. Okay, there are 5 more. So 5. Oh my gosh, are you kidding me? That was mistake number 7. 5 more. I'm never using that one again. I'm throwing that away. 5 more, right? I'm going to rewrite that as 5 more. So there's 5 more purple. All right, there are 5 more purple than green ones. Okay. There are 2 fewer orange than green ones. Notice how we're comparing everyone to green ones, right? And there are the same number of yellow as green. Woo! And then there's a total of 59 Skittles. Man, that was a lot. We got this though. We got this. Let's start with up here in the pink. All right, 3 times more red than green. All right, so red equals 3 times green. Boom, that's done. There are 5 more purple than green. So purple equals green plus 5. That's what it means to be 5 more than something. You add 5 to it. Okay, there are 2 fewer orange. So that's green minus 2, then green. And there's the same number of yellow as green, and then green has green. Okay, so remember, we're going to take the red Skittles plus the purple Skittles plus the orange Skittles plus the yellow Skittles plus the green Skittles, and there's 59 Skittles in a bag. By the way, I looked that up. That's the average number of Skittles in a regular size bag. Let's go ahead and substitute in. So R is 3G plus purple is G plus 5 plus orange is G minus 2 plus yellow is G and G is G. Okay, let's simplify. 3G plus 1G is 4G plus 1G is 5G, 6G, 7Gs. Okay, G. And then we have positive 5 and minus 2, that's plus 3, equals 52. That equation just got much simpler. That is my equation. Okay, let's solve it. Let's go. 52, 59. Oh, I'm glad I caught that. That would have been a nightmare if I would have not caught that. 59. All right, let's solve it. 7G. Ooh, that was my microphone. 7G plus 3 equals 59. All right, inverse operations. Subtract 3, and I get 7G equals 56. Okay, this is getting easier. We're close now. Inverse operation of multiplication is division. So G equals 57. 57. Come on now. 8. That means there's 8 green ones. There's 8 green. All right, now I'm going to go ahead and I'm going to check it. So here's what I'm going to do. I'm not going to write it out. I'm just going to come over here and I'm going to put them in one at a time. So reds are 3 Gs. So 3 times 8, because G is 8. Plus, that's not a plus. Plus, purple is G plus 5. So that's 8 plus 5. Plus, G minus 2. 8 minus 2. Plus, G plus G. Oh, B59. Let's go! All right, we're good. Well done, people. Well done. Remember to stay strong, stay focused. Let's get this done. Make sure you like. Make sure you subscribe. Give a little love out there. Stay strong. All right, be good. Bye.